Hello! Welcome to today's lesson on the life cycle of a star similar in size to our Sun. In today's lesson, we will explain the life stages of a Sun-sized star, from its expansion into a red giant, the shedding of its outer layers to form a white dwarf, and its eventual cooling into a black dwarf. So far, you are familiar with the shared life stages of a star and can describe them. We have looked at how stars are born and the main sequence stage of a star's life, where they fuse hydrogen into helium in their cores. Building on this foundation, we can now delve deeper into the later stages of a star's life. Let's get started. In our previous lesson, we explored the early stages of star formation, which are shared by all stars regardless of their size. From their beginnings in nebulas to the protostar and main sequence phases, these stages lay the foundation for a star's life. However, as stars move beyond the main sequence phase, their life cycles diverge depending on their initial size. Stars that are similar in size to our Sun follow one path, while much larger stars follow a different journey. In today's lesson, we'll focus on the life stages of stars that are about the same size as our Sun. Let's now dive into these stages. First, we have the red giant phase where the core contracts. As a star like the Sun ages and runs out of hydrogen fuel in its core, hydrogen fusion slows down. As it then has less outward pressure from fusion, the core begins to contract under the force of gravity. However, as the core contracts, it heats up. This increased heat causes hydrogen in the outer layers of the star to start fusing in a shell around the core. Following this, the energy released from this outer shell fusion pushes the outer layers of the star outward. This leads to the star swelling up to a size many times greater than its original size. This expansion of the outer layers leads to a decrease in surface temperature, giving the star a reddish appearance. This is why this stage is referred to as the red giant phase. Leading into the second stage, the white dwarf stage. The red giant phase continues. The star will eventually shed its outer layers into space, creating a cloud of gas and dust known as a planetary nebula. What remains after this shedding is the hot, dense core of the star, now visible as a white dwarf. This white dwarf is incredibly dense, with a mass similar to the Sun, but compressed into a size comparable to Earth. Then we move on to the cooling process. Since fusion has ceased, the white dwarf no longer produces energy, and it shines solely from the residual heat left over from its active life. Over billions of years, it will gradually radiate away its heat and cool down. Finally, the star has its final cooling. After billions of years, the white dwarf will cool down so much that it no longer emits significant heat or light. It becomes a black dwarf. A black dwarf is essentially the final stage in the life cycle of a star like our Sun. This is the ultimate fate of a Sun-sized star like ours. To summarize, we began by exploring the transition of a Sun-like star into the red giant phase once it exhausts its hydrogen fuel. During this stage, the core contracts while the outer layers expand, causing the star to swell and appear red. Next, we have the formation of a white dwarf. This occurs after the star sheds its outer layers, creating a planetary nebula and leaving behind a hot, dense core. This white dwarf will shine from residual heat but no longer undergo fusion reactions. Finally, we have the black dwarf stage, where the white dwarf cools down over billions of years, eventually becoming a dark, cold remnant. In today's lesson, we delve deeper into the later stages of the life cycle of a star similar in size to our Sun. We began by exploring the transition of a star into the red giant phase once it exhausts its hydrogen fuel. During this stage, the core contracts while the outer layers expand, causing the star to swell and appear red. Next, we learned about the formation of a white dwarf. This occurs after the star sheds its outer layers, creating a planetary nebula and leaving behind a hot, dense core. This white dwarf will shine from residual heat but no longer undergo fusion reactions. Finally, we discussed the black dwarf stage, where the white dwarf cools down over billions of years, eventually becoming a dark, cold remnant. In summary, stars like our Sun evolve predictably, transforming from a red giant to a white dwarf and ultimately a black dwarf. This knowledge enhances our broader understanding of astrophysics and the processes that shape our universe. Watch the rest of the GCSE physics course at Sophos Education.